Some heavy traffic in the neighborhood today. Hey folks, welcome back to the channel. I thought I'd do a little machining on this video. I haven't done a machining video in a while, considering this is kind of a rinky-dink machine shop. And no, I don't have my new lathe yet. That's a whole nother story that I may do a video on. I'm not sure, because it's kind of a sad story. But anyway, it doesn't matter. Let's stick to the topic at hand here. This is an original bolt for the rear torque arm of the Z1-R. And it goes between the torque arm and the rear caliper. And for the life of me, I can't find these anywhere. I've looked on eBay. I think CMS NL over in the Netherlands there may be the only place, if they even have it. But I just can't find these. This is a special shank bolt, obviously, with a hole for a cotter key. So what I ended up doing was, as you can see, is I went ahead and made one out of stainless. Hey folks, it's me coming to you live, or in the future, from the editing cave, maybe not so live, and I may not even be wearing pants. I guess that's irrelevant. I just wanted to let you know that I sort of found a place to find them. Well, actually one place for sure, but this one in this picture is one bolt. That's, I believe, the rear one, the long one, on eBay, and it's in pretty cruddy shape. So that one's out. Now the other place I can find it is a place called Z Fever. It looks like you can get that kit that Z Fever at least carries. I don't know if they make it or they sell it, but you can get it there, or also a seller in Australia. Not terribly bad and not completely unavailable, but you know, still pretty expensive, and you'd have to wait a heck of a long time to get it. Now I'm going to show you this one, how it goes in and where it goes in, and then I'm going to make another one we need for the front of the torque arm where it goes into the swing arm, and I'll do that part on camera to show you how I did it. So hopefully you get something out of it, be interesting to watch besides me stumble over myself in regards to doing other motorcycle things and, you know, my typical day, my typical results. Okay, so here's the rear torque arm, the rear of the torque arm rather. There's actually a little square boss on the backside, rectangular shape rather, that captures an edge of the bolt so it doesn't turn when you turn the nut. In other words, you don't need to have a wrench on the inside. And this is a 17 millimeter bolt. This front one's 17 as well. And then the outside nut is a 14. So let me put the old one in first to show you really quick. It just slides in, you know, said the wife. Yes. And then, I know that's a lot of stick out here, but that's just the way it is. This is the correct bolt. And then you put the nut on it, torque it up, and then put a cotter key in it. This is the new one, goes in the same way, but I just want to see how it looks. There it goes. A little thing that holds it. You just put a nut on. And I don't really have the nut that I like. I mean, I like my nuts, but not this particular one. We'll use it for a while. Torque it up, put a cotter key in, you're done. So that looks a hell of a lot better than this does. And it does, again, go from the back. You know that because it's got that little boss there. I guess you could flip the torque arm around and have it on the outside, but I'm pretty sure it goes this way. No, it goes like this. I just checked the parts fish. Comes in from the back side, said the wife. Yes. And then tightens up, like I said, and you put a cotter key in it. Which kind of makes sense because it'd be harder to get in here and torque up a nut than it is out here. Just put the bolt in from the back. The front one actually is like that too when it's stock, but we have a modified swing arm here, so we're going to do it a little differently. It's going to go in from the outside, and that's the one we have to make right now. So let's go ahead and get on it. All right, as I said, we're going to make one of these bolts out of one of these bolts. I didn't say that before, but this is what we're going to use. But I did say we were going to make one of these, and we're going to use this. 1/2 inch stainless steel, 3/4 inch head, I don't know, 4 inches long or so. I picked this material because this is, well, I think it's 12 mil, but I have to measure an imperial. I don't have any measuring tools for metric. It's 470 thou, and I knew that this would be around 500, so I had some material to take off. I certainly didn't want a piece that was smaller than that. It wouldn't work. So that's why I chose this down at the hardware store. This was $5, $4.99 to make a bolt, but like I said, you can't find these, so I think that's pretty cheap. I'm going to change up my order of operations a little from doing the other one that you just saw. And I'll tell you what the order of operations I believe is going to be. What we're going to do is we're going to take this and first kind of guesstimate the overall total length and, you know, just make it longer. Not guesstimate. We're just going to make it longer than it needs to be by, I don't know, that much or so. I'm going to go ahead and cut that off by hand because this is too short for the bandsaw even. And then when we bring it back here, we're going to chuck this end up here, the head end, in the 3-jaw. And very carefully face that end that we just cut with a hacksaw. Then we're going to drill a center, and that way we can put a live center in here. And then we're going to do some turning. I don't think we'll be able to get this rigid enough without it chattering on this old lathe without putting a center in it. So I'm going to probably actually make it even longer. Because I want to be able to cut that center out of it when we're done. So I will cut this off appropriately, so it's just not full length. We don't need it full length. I did do the other one full length. It didn't matter. You know, it's stick out we don't need to deal with. So once I do that, we'll come back. Next operation is just going to be facing the end. Pretty standard stuff. Yeah, this has got to be running pretty true before I do a center on it. I wish I could turn it without it, but not stainless, no way. See, there's just not enough material to take off for it to be, that's better, to be out around. I don't need to indicate it though, it's not that critical. Just do it by eye. I just wish I had a new lathe, let me tell you what. Somebody needs to buy this one. I mean, it works good for doing this little crap. It's too hard to change the feed rates on this one as opposed to another lathe where you can do that real easy, and I could probably change the feed and the speed enough to keep the chatter out of it, but I'm just gonna skim it right now. I'll put a little load on it, said the wife, but right now we just have to bring it down. It doesn't have to come down much, you know, it's at just under 500,000, so 495. All right, we're at 470, so we got to go to 490. Take it down from 495. So. Let's see where we're at. He ain't cutting all the way around, so I'm going the low side. I only took 5 thou off, so let's see what we can do. 70, 80, 90. Try 10. Yeah, she wants to go. It's at 480, so we'll leave it there right now. It's 10 thou over. It'll need to come down to 470 rather, the final dimension. So that's good. Maybe 78, so 8 thou. Doesn't matter. As long as we got some material left, because I want to flip it around. I probably do need to clear up that that step I was talking about right now, because then I'm going to flip it around and I need to measure the thickness of the head. So, and make it the same. Gotta come off about 45 thou. Gotta come off? Yeah. 45 thou's gotta come off, rather. Make it the right thickness. Pretty straightforward operation. Just rough it in. About 15 thou to go. It's probably about 10, I'm guessing. Yeah. I don't have a Z-axis DRO obviously on this, so I'm kind of guessing. I could put an indicator on here, but not that important. What we'll do now though is lock the carriage so we can get a nice square shot at it, you know, square edge. Try that. I bet you're right about there. This isn't critical, you know, but I like to keep it as accurate as possible to the original. Now we're gonna go a little bit more nice and slow. 243, that's fine. So it's basically the same as the other one, thickness wise. We'll be putting these radiuses on after we mill the hex down to where it's supposed to be. Put it back in the lathe to do that, of course. So now we gotta do thread. Okay, I need to make a mark on the workpiece, which denotes where the shoulder is, and then we'll cut the threads, major diameter, down to that. And well, you know, again, it doesn't have to be critical. We'll say that that's like 750, 740, something like that. I do want to make it as accurate as possible though, so I'm going to go a little bit more, and I'll use the depth side of this when we get to that point, and we'll make it exactly the same, or at least within a few thou. That should be good. We'll make it like 775, 780, 220, 221, whatever works. Make a mark. Probably a little long, but that's okay. Longer is always better, so I heard. Major diameter of the threads is 385, 384, 385. The other one I made about 388, because I'm counting for a little bit of wear in these thread peaks over the years. So we'll do it about 388. And we'll cut this final one down later on. This section here we know is 10 thou over. We want to bring this down to final dimension, though. There's really no need to do this right now, because in case I got to turn it around and do something else on the face or something, I want to leave this a little bit big. We can always cut it down later. Doesn't have anything to do with the threads. So we're at 480, and what I say, I want to go to 390, 388. So almost 100 coming off of it. I don't know if this is going to take it, but we're going to try 20. Whoa, I guess not.
Well, I guess not.
That was dumb. This happened on the last one as well. And I don't really worry about it because we got to mill this down anyway. But I'm like, that was dumb. I tried it anyway, what the hell. Let me go ahead and get this thing set up where we got it in the center. Yeah, that was being held in the chuck by hopes and dreams. So now we got the center going. We'll just use that other cutter and then cut that. It doesn't really need to be a shoulder there anyway. I guess it does. But yeah, it does need to be somewhat of a shoulder there. What I say, I need to take about 95 off. Let's go with 40. Which is a lot to ask this little lathe when you're cutting stainless, even with carbide. Yeah, I think I just chipped a insert. Oh, Lord have mercy. What is going on here? All right, fine. Be that way. 20. All right, all right, what happened was that much of a tool load actually pushed the workpiece further into the chuck, thereby removing it from end support. So that's why it started chattering. But we got plenty to take off, so we'll just clean that up. Guess we won't be so zealous. Couple thou to go. I'm just going to give it a little bit and do a kind of a spring pass here. It should be about right. And we'll file the rest of it in. Maybe added a couple of thou to a spring pass. It should be right about where we need it to be. So confident that I'll back the tool off. Of course, no biggie. Just touch off again if necessary, right? Yeah, about 89, so I'm going to file the rest of it in. and get it where I want it, through 87, 88, just a little bit bigger than the original one. I've come to find that these old bolts do have some wear on the peaks of the threads. I'm just going to touch off on the end, and I'm going to give this this die rather a better chance by giving a little lead. Cut it down. This is all scrap at the end anyway. Switch the tools out. Get this corner sharpened a little bit. Could finish off that corner. I'm going to wait on that though, because I need to put some relief in for after the thread's in, and I could probably do that at the same time when I bring that corner in. Kill two birds with one stone, so to speak. But I just want to dress it up a little bit, because it's kind of rough. All right, this is kind of a simple setup, but you know, it works. It's not a critical thread. I don't have a holder, rather, for my floating die holder for the lathe for this size die. So this is the best we can do. It worked before. All I need to do is get it started. I got the lathe in back here, so we'll bump it and see what we can do. All right, now we're good and started. So we're just gonna let her eat. She's just up against the ways here, and it cut the last bolt threads really nice. So let's see if it does it on this one. Doesn't like it, but it's doing it. Yeah, usually what happens is it'll stop and the belt will slip, which is fine. Now, if I only had a lathe that had a reverse, I'm going to change that up just a little bit. We'll do this diameter with tailstock in place, give it a little support. I could leave this to the very, very end because why is that? Because we still got to put this in a collet chuck and recut the hex. But in order to dress up this hex bolt head that we're going to essentially reform, we do have to chuck it back up here, but it's not going to be a very heavy, you know, force on the chuck, and we're not going to tighten it that much, in other words, so it's not going to screw it up. So we're going to go ahead and bring this down to this final dimension, then we'll do that. That way I can make sure the inside edge is cleaned up as well. I'm gonna beat that with a stick. Thou under, thou and a half, that's fine, close enough. Now we can remove the tailstock support. You know, the end measurement of the bolt, length of the shank from the edge of the, where the threads and the shank meet to the face of the, inside face of the bolt. And that's 740, it looks like. Again, not critical, but I want it to be pretty close. We'll go 735, I guess. It's kind of hard to measure. It's a unusual surface to measure. I'm gonna start doing that. $39, I think. That's pretty good. 38 and a half. I'll go with that. It's kind of hard to measure, but close enough. All right, we'll deburr all this in here in a minute, but I'm gonna have to run that that die up here a little bit further. What we're going to do now is I'm going to cut it down the length, then we'll move it over to the mill, put it in a collet chuck, and we'll do the head of the bolt, bring it down to 17 mil with a ER32 collet block. And then I'm going to show you the drilling of the cotter keyhole, but on the other one. I filmed the other one, I don't need to film it again. So you'll see that one, it's a little bit longer, where I drill the cotter keyhole in it, and then we'll finish the video up. That'll be it. We're going to go ahead and leave this one a little long because it goes into a different kind of a setup than the original one. I'm going to err on the long side. It'll be on the inside anyway, facing inwards, I should say, where the cotter key is going to be, so you're not going to see it anyway. And it won't get in the way of anything. I don't feel like setting up the compound to cut this, so we'll just file in a little chamfer on it. Thread lead, thread start. Battery died, so I'm not sure if you missed anything, but it's pretty self-explanatory, that rest of that lathe work. So all I'm going to film now is how I'm going to do these hexes. Pretty interesting here because, you know, you have your six-sided collet for a six-sided bolt, but we have to pick up the level of the bolt. We can't do it straight over here like this because there is no flat when it's in a collet like this. If it was a square collet, it'd be another matter. But I need to pick up a flat because all we're doing is milling down the existing flats. And I don't have to take much off, only 41 thou from a touch off, and then just go around 5 more times, or 6 times in total. So what I'm going to do to pick this up, it worked pretty well, is just take 2 squares like this, actually like this, and just hold one against the other. They're fiddly, but you get the idea. Yeah, that'll work. Yeah, as long as it's certainly well within the 41 thou, we're good. So now we'll just tighten down this ER32 collet really good. There we are. Now we're ready to cut. I'm using a 1/2 inch brand new 2-fluted end mill. The DRO, the Quill DRO says that we are there. Just going to use the Y-axis. All right, so the old one is about 665 across the flats. The last one I nailed at like 660, close enough. This one is 650, so it's a little smaller, 15 thou, but let's see if they're all the same. Yeah, it's still good enough. I mean, it's not as accurate as I wanted it to be, but it'll definitely take a 17 millimeter. The final operation, besides a little deburring and polishing, is we need to knock these edges down, you know, kind of like you typically see on a bolt. They're not sharp edged. I mean, there are some that, of course, are sharp edged, but we don't necessarily want that. This is what I'm talking about. On the front of the bowl, you can see it's knocked down, and a little bit on the inside, but very, very little, if any. Now, on the one I made for the other one, I did knock that down a little bit more. But we're going to make this one a little less. Don't need much jaw force on this one. Just going to use the angle of the tool. Try that. A bit more. Yeah, that'll be about good on the inside, I think. And then we'll just deburr the rest. And the outside gets a more generous one. Where it starts to come up on the flat. I think that'd be about it. Yeah, that looks good. Let's take it out. I'm gonna go ahead and drill the hole for the cotter key. And so how I'm going to do that is I'm going to establish a flat first on the threads with a 1/8 inch end mill. Just in the drill chuck is fine. So I used an edge finder here and found the edge. Now I'm set up with a dial indicator out of shot. Well, actually it's kind of right there. You get the picture. And then we're going to move over 100 for the edge finder rather, and then move over half of this distance, which I think, yeah, it's 195 thou. So we need to move over 295 thou, because this is 390, I believe, or 3 something, 370. I just measured it, it's fine. 100 for the edge finder, so now we're centered with the edge of the thread. And then we'll go 195. This, as you saw before, is an M10 1.25. And so I just made it the major diameter for an M10 when I turned it down. The drill bit is, I don't know, it's a numbered drill bit, it doesn't matter. I don't have any metric drill bits this size. So this fits into the old one because we're using the old bolt as a guide. Now we're going to establish that flat at the appropriate length in from the back. And all I'm going to do is touch off and then move over, I don't know, whatever it looks good for that based on the other one. Probably just eye that in, it's no big deal. There's a lot of stick out on this and I made it exactly the same as the original one, so. I'll probably end up throwing this back in the lathe and just skimming that off. I really didn't mean to make such a mark in it, but it is the way it is. I could have just stuck a piece of paper in there, but I'm like, it's not that critical. I think I'll bring it in half the distance of the bit, which is a 1/8, so 0.62. So now we're lined up with that, and I don't know, maybe I'll measure this and be a little bit more precise. The whole distance from the end on this one looks to be about 190, so that's what we'll make it on this one as well. Now you gotta go real easy with this, especially in stainless. All I want to do is make a little flat. About right there. I'm going to use a number 3 center drill. Center drill that out. And I know the 1/8 end mill is bigger than the drill bit that we're using, but that'll be obliterated by a chamfer on there anyway. You're never going to see it. I think we ought to get a sharp one. I had to use a bigger one. None of my number 3s are sharp. I only have one. All right, that'll work to start it. As long as it's got a place to start. No need to reinvent the freaking wheel here. All we have to do is put a little divot in it so the drill's not going to wander, because drilling into the threads are a real pain in the butt. Really no other way to do it besides establishing a flat. Now I know I'm not running this mill fast enough for this tiny drill bit. And I don't feel like changing the belts around. This thing should be whizzing, but it ain't gonna. Because I don't feel like changing the belts. So hopefully we don't break it. That's how you break a small bit like this. We'll just take it easy. And yeah, I know, don't even need to use a milling machine or a drill press on something like this. You could easily just, you know, file a small flat enough to get a purchase with a bit, and then run it through by hand. It'd be perfectly fine, but I like accuracy, so this is why I did it the way I did it. So that's good. So we just got to chamfer that out, and then we're good on that hole. They look real good. I like the way they came out. And they will definitely work, which we'll see here in a minute. Because if they're not available, you just got to make them, you know? And I'm going to go over here briefly what a cost of this would be if you were making them for somebody. Because I got some timely information on another creator's video to share with you, which actually does a better job of explaining that. Rear one is the longer one, said the wife. And then you just put a nut on this guy and torque it up. And put your cotter key in, and everything is hunky-dory. Now the front one normally had, or I should say the original one, it had a through bolt as well, and it came from the back side. But as you know from my videos on doing this swing arm, this guy has to go in this way from the front. There's threads that it captures in the back and locks it in. It's a little tight because well, it just is. There we go. And I'm glad I left that a little bit long, because that little hole, I'll show you what I mean, that little hole for the cotter key on this one, I just got kind of a feeling on that, is just sticking through. You can see it right there. So yeah, that works out pretty well. And that looks a hell of a lot better, you know, than having those old bolts in there. This versus this, you know, so it looks a lot better. I can guarantee you that stainless is as strong, if not stronger, than this steel is. I'm sure this is not hardened steel. It certainly wouldn't be. Same for the rear, that looks good. Now the nut, I'm gonna have to change that out. I'm not exactly sure what to put on there yet, but this is all I had on hand. But it does look pretty well, and it is a flange nut. I can't honestly remember if a flange nut was in there or not, but we may just leave that. Give it a torque, put the cotter key in, boom. Now if the parts fish calls for a split washer, which I really doubt because it's got a cotter key, we'll use that, but may put a flat on it, I don't know, but with a flange you usually don't need one. So this guy I might put a large enough one on up, you know, on the front here, but I don't even know if we'll do that because I don't believe the original had one either. So yeah, pretty cool. Yeah, so you can see these came out real well. I'm real happy with the way it came out. They work, they're going to be strong, and they're not going to rust. And they're way better than these old ones. Now there's a couple options you can do with these. I'll cover these briefly in this outro. But you know, I did an extensive amount of searching on these, and I couldn't find them. Now, are they available out there somewhere? Possibly, but you know, you really have to weigh your time and the ability to find stuff, especially if it's in another another country or on another continent, even to determine whether or not it's worth going that route. I chose to go this route. So let's talk about costs and some other options as far as material. Well, obviously, these are pretty expensive. For two reasons. Number one, they're stainless, and number two, I bought the long ones. I wasn't sure of the length that I would need, so I bought the longer ones to be safe. The shorter stainless bolt was maybe $1 or $2 less, so it wasn't really that much big of a difference, but still you could save a couple bucks there. You might ask yourself, can we use like a zinc bolt or something like that? I have one here. That might be a stainless bolt. Let me grab this one instead. I know it's a little extreme, but it's the only zinc bolt I have right now. These have the markings on the heads of them. Now, some Japanese original bolts, like this one, have markings as well. But you know, that's OEM, and this is just a single number. And these are called upset bolts with a little flange on the top edge of them. That's what Kawasaki calls them, at least. And if you took one of these and did the same operations, you'd be back to square one. You'd have a steel non-protected bolt that's going to rust, and you'd have to zinc plate it or something. Well, if we're going to do that, we might as well just take these guys, send them out, and have them zinc plated. And you can do that. That's one of your options. Find a place that'll do them. How much it'll cost for just 2 bolts? Probably a lot. Probably a lot more than what it would be just to make them like I did. All right. Now, speaking of cost, from a cost perspective on this job, you know, to make these guys right here, it's going to be difficult to charge like hour per hour or minute per minute what you put into something like this. Figure I could, you know, I was filming and so forth, as you know, during it, so it probably adds 2 to 3 times the length of time needed to make these things. So I would say I'd probably need about an hour and a half maybe to make the first one, and I could probably crank the other one out in an hour. That way I kind of, you know, refine my order of operations on the first one and then do the second one a little more efficiently. So if you multiply your hourly rate by, you know, whatever your hourly rate is, you know, that's what's going to be the cost as far as your time plus materials on a job like this. So in reality's sake, you know, these 2 bolts probably are, you know, $150 worth of work. Can I charge 150 bucks for them? Probably not. So I'll add something into the ticket for the materials, certainly. That'll be the full price of the materials. And then something for the labor. But, you know, I lose money on a lot of stuff, so it's not like anything new. But, you know, for other businesses that can't do that, then I don't really know what the answer is besides mass production. This would be a great CNC job. If somebody had a CNC and they wanted to crank these out, you crank out enough of them and you sell them, you can lower the price substantially, right? So finally, you know, I was working on these the other day, and I took a break for lunch, and I sat down in the air conditioning because it's hotter than hell, and I fired up YouTube, and I found a channel from a gentleman. His channel's name is Jeremy Makes Things. I'm going to put a link to his channel in the description because he goes over the exact same thing about making 1 or 2 off parts. Now, in his case, he was doing it for a Patreon. And I don't have Patreon, but that's how he said he essentially justifies the cost because he made a couple of stainless hose barbs or hose fittings or something like that. Look at the video, you'll see what I mean. And anyway, he talks about the cost of it and how it would be very difficult for shops to justify making 1 or 2 off parts. Ergo, that's why a lot of shops refuse to do 1 or 2 off parts. And so he talks all about that. Again, I'll put the link in the description. It's a good video, just kind of timely. I was in the middle of doing 1 or 2 off parts, and I went in for a break and watched the video on him explaining his rationale on the costs and I guess the pros and cons of making 1 and 2 off parts. Now that said, I will do 1 or 2 off parts for people if they want me to make things like this. Especially after I get my new lathe, whenever that's going to be, I can be a little more efficient, because that old lathe, you know, it's difficult to even work on stuff like this, but it does work on it. You have to make compensations and adjustments. But like I said, I'll do the parts. I'll put my email at the end of this video if you're interested in me doing something. You got to send me what you want, what material you want, preferably a drawing and how many, and I'll get back to you with a quote and say, well, this is what I can do on that. I can make these bolts or these fittings or whatever you want me to make out of nothing exotic as far as materials, but something like this in this job, absolutely. So yeah, well, that just about sums it up there. I just wanted to go over those last bits of information at the end of this video. Definitely give Jeremy Makes Things a look-see. He's got a nice channel. It does good work. I think he's up in New Hampshire, so you folks in the Northeast might get a kick out of him. But anywhere, I would recommend checking out that video at least, or subscribing to his channel. Yeah, real cool guy, and a nice old machine shop with old machines, and he makes do. It's one of these things where, like I do, with machines that aren't exactly designed to do certain things, he makes do, and he does a really, really good job. So I hope you found this to be a really, really good job, or entertaining video, maybe informative. If so, you know what you need to do. You need to like, subscribe, ring the bell, the notification bell, but the liking and subscribing is really important for my analytics. And that way you get notified when I put more crap like this up. So until next time, as always, thanks for watching. Don't just repair, restore. We'll catch you on the next video.